This is Group 30's mini project, presented by myself, Kiana, and Abby. First, I'll be going through problem 1, spool on a truck bed. In this problem, we explored the motion of a spool on a truck bed. Task 1 involved assuming no slipping occurred. Using Newton's laws and rotational dynamics, we calculated the spool's angular acceleration as 3 radians per second under a truck acceleration of 3 meters per second. The friction force required was 750 newtons, and we found that the no-slip condition was true when the static friction coefficient exceeded 0.153. MATLAB was used to verify these results, showing strong agreement with the hand calculations. Task 2 examined both slipping and non-slipping conditions. We derived general equations for the angular acceleration, linear acceleration, normal force, and friction force. We then used MATLAB to test different cases and observed how the spool's behavior changed with different friction coefficients and accelerations. The simulations confirmed that higher acceleration caused slipping, validating our analytical findings.
Hi, I'm Abby, and I'll be presenting the Virtual Lab 2, which explores the principle of impulse and momentum. Here's my free body diagram displaying the ram, cart, and the green block which is attached to the spring. The position of the cart on the diagram is where it will be measured from, just before release. It will start at rest and have an initial velocity of 0. Starting with task 2, these are the known parameters that will be used in each experiment. The Simulink model displayed on the right side of the slide will be used to obtain the results. For the first experiment, the results will be obtained from an inclined angle of 10 degrees. The cart will be released from a distance of 1 meter to the block, and the spring stiffness will be 1 by 10 to the 4th power. On the right-hand side, you can see the results showcasing the position, velocity, and impulse forces over time. For experiment 2, the spring stiffness has been decreased to 1 by 10 to the 3rd power. This has a major impact on the results when comparing to experiment 1, and you can tell that the block absorbed a lot of the impact force and shortened the duration of the simulation. Finally, for experiment 3, the spring stiffness has been increased again, and these parameters will be used. The results are somewhat in between experiment 1 and 2. This is expected because the high spring stiffness will counteract with a decrease in the incline and length. For task 3, we utilized the principle of impulse and momentum, and the useful equations are shown on this slide. When analyzing the MATLAB results, I was able to determine that the time at which the first impact occurred was at 1.083 seconds. The red and green dots represent these time frames. To conclude the task, the predicted and measured exit velocities are shown. These compared well with each other with a small difference of 0.004, which displays an accurate result for the experiment.